In this case, we basically have the same structure as we had in the previous problem, but now instead of a load, we're going to put a moment. So if we go back, we look, instead of having a load at this point at point B or at point D, we're going to have a moment acting at point B or at point D. And that moment is 36 Newton meters. So we can go through the exact same, we already have the position vectors. And now our force and moment balances are going to be a little different because now we're going to have external moments acting in here. So when we write those down, we'll have forces are only A for the entire structure. This is for the entire structure. We only have the restraint forces A and E acting. And then we have, I'm going to include both moment B and moment D. And those moments would be something like, let's see, they were in the clockwise, so it would be like 0, 0, minus 36 Newton meters. Those would be either moment B or D. So I'm going to solve it for each case, and then set one to 0. And then in the second set of equations, force and moment balances, I just used let's see here, I just used the lower part, the lower member of the structure. And so we have forces E and C acting. So we sum over the forces E and C. And now in that side, on that member of the structure, we only have moment D acting, because moment B acts on the upper structure. So what we can do is we can find that FA, and we find out that FE is actually just minus FA, which we could have determined because if we look at this structure, there's no external forces, just external moment. So a force and moment balance says that, or force balance says that these two things have to cancel each other out. So a force balance on the whole structure says that we have to have these two things cancel each other out to keep this thing in equilibrium. So that's no surprise. And so we see here that this one, FA, the vertical or the horizontal component doesn't depend on which one of these, where we put the moment. It's 9/50 newtons in either case. And in the vertical component, we'll get a larger force, a larger magnitude of force if we have the moment at D than at B, because we have 5 instead of 3, and the sign will change. So we'll have in the first case, at A we'll have a vertical force, and at E we'll have at A we'll have an upwards force, upward vertical component, and at E we'll have a downward vertical component. And in the second case, when we have the moment at point A, when we have the moment at point B, we will have a negative vertical component at A and a positive one at E. So the sign changes on the vertical components at the reaction forces.